Having learned about Manetti Marelli's WinTAC system in the first installment of our two-part video series on MotoGP electronics, which allows teams to visualize and analyze the data collected on track, we now come to part 2, where the so-called SISMA tool for configuration of the electronics is taken under the microscope.
In part 2, we are going to talk about the other tool, which is called SISMA, and you can see it on the screen right now. SISMA serves for two main purposes. One is to be able to communicate with the ECU, to be able to send the channels that then later on you will see on WinTACs. Each strategy has associated a number of calibrations, of parameters, of numbers, scalars, vectors, tables or maps. These are the numbers that the technician needs to put inside the ECU to make the bike change its behavior according to pilot needs or performance. So yes, when the bike comes inside the box, the pilot tells something that's not right, you analyze it with WinTACs, then you open SISMA, you go to the particular strategy, for example traction control, and you change a series of numbers to change the behavior of the traction control. Samely, you can change the behavior of the anti-wheelie, you can change the behavior of the lambda control. Some tens of strategies, different strategies with many hundreds of parameters, with thousands virtually of numbers. When we talk about strategy, we talk about vehicle general behavior. Some strategies allow you to optimize, to change some things depending on the position of the bike inside the track. Actually, our system is able to separate the track in 25 sectors. And on each different sector you can have a different approach, a different quantity of traction control or anti-wheelie or other strategies. So you are able to optimize the bike behavior actually corner by corner. Each time the finish line is detected, the distance done by the bike gets to 0. From that on, the distance done by the bike helps you to understand the position of the bike on the track. Each sector can have some hundreds of meters, and to change from one to the other, you do not only need to go over the distance, you need also to achieve other circumstances. So this ensures that you are not going to mistake your sector. The biggest strategies can have about 100 parameters to be calibrated perfectly. When I talk about parameters, I am not talking about numbers. For example, one parameter can be one table with hundreds of numbers. Our strategies do not change lap by lap. It is the pilot which changes the level at will. So if the pilot understands that the wheel is starting to slip too much, he can change at will the setting for the traction control or the relationship between gas and throttle to make it go smoother. Our traction control, as all the high-level traction control, works on slip values, on differences between the rear wheel and the front wheel speed, and they are also based always, all the most advanced systems, on the lean angle of the bike. So basically, very basically, it's true that the more lean angle there is, the less power is allowed. The number of levels depends on the strategy. For example, for the traction control we have 5 levels possible. For the anti-wheelie, if I don't mistake, we have 3. 3 levels that, depending on the numbers put by the technicians, are going to give you more or less intervention. Our job is to explain how strategies work, to be there if there is any problem, to receive suggestions, to provide assistance, but to put the right numbers, that's their job. We will not do it for them.